How is it going? The preparation?
Like just started.
Started, okay. Yeah, so as we had said that like the most focused part in the final course is estimation and hypothesis testing. So we'll just go to we'll start the estimation part. Do you have any specific doubt in estimation and hypothesis testing?
Nikita, this
Ma'am,
is the
bias or variance and that those kind of things, ma'am. Bias or variance.
Bias of variance, okay.
Ma'am, in week 9, model estimation is also coming. Model estimation.
What do you mean by model estimation?
That there's a topic in week 9, model estimation.
Fitting distribution.
Of
model estimation, right? That is one of the doubts.
yes, ma'am. I'm not getting that topic.
Okay. Anything else?
In the
No.
formula file for week 9, there is model estimation, likelihood ratio test, and goodness of fit. I mean, this
Alright.
is written in the formula file, but no questions or any theory around it. If you can just give some information around
You're
it.
talking about the formula file for week 9.
Right.
Okay. Just let me check once. I couldn't see likelihood ratio and all.
I'm just checking whether it should be in week 9 or somewhere.
I think
It's in
we
week
are
11.
talking about week 11. Yes.
Week 11, right? Right.
Yeah. So
Sorry.
I think that went by mistake. So all those additional content that we have put in week 11.
Mm-hmm.
So initially it was not a part of additional content. So I think that's why it went. So you can skip those part. It is not for the statistics to course right now.
Okay.
We
So
have
just to be
additional content, like if you are interested, you can just go through it and study about it.
sure, just to be specific, likelihood ratio test, chi-square test for goodness of fit, and test for independence.
They
All
are,
the three. We
are
can
in
skip it.
additional content. Yes.
Yeah.
If you are
Okay.
interested, you can study, but
Fine.
these are not for the example.
Fine. And you'll take up model estimation right now in terms of explaining it.
Yes, I will take it.
Sounds good. Okay. There are some specific questions also that I've written from practice assignment and graded assignment. Do you want to make a note right now or?
Yeah, I will write it down.
Okay. So week 11 practice assignment question 2, question 7.
Week 11.
Practice assignment question 2 and question 7. And graded assignment week 11 question 3. So I have specific doubts. Once you reach that, I will specify what exactly I want to ask in it.
Question 3.
Question 3, graded assignment week 11.
Anything else?
Ma'am?
Yeah.
Hello, ma'am. I have a doubt in week 9 of tutorial 2, question number 2.
9 of
Tutorial 2, question number 2. I have a doubt in feedback given there, no? So I have a doubt in there.
Okay.
And ma'am, would you take one example of that testing of sample proportions and explain it? It would be good for me. Yes, ma'am.
Right. And
Ma'am, variance of estimator, ma'am, variance of estimator.
variance of estimator.
Ma'am, I have doubt in p-value and finding the p-value. There are some activity questions also. If you can solve for me one question.
All right.
Ma'am, there is a question in activity 10.6, question number 3 regarding the p-value.
Okay. Any other topic?
Ma'am, activity 10.7, question number 3 and 4.
Activity 11.7,
No, it's 10.7.
10.7.
Question 3 and 4.
Okay.
Ma'am, tutorial 2 of week 11, question 1.
Week 11, tutorial 2, question number 11. Okay.
Question number 1.
Okay. Sorry.
Hello, ma'am.
Yes.
Ma'am, week 11, activity 11.7. So in this activity, so there is we have to say yes or no. So I can find which one I'll have to accept or reject, but I'm
Can
not
you
getting,
tell me the question number?
ma'am, exactly all the question like 11.7 I have done like which one have to like accept or reject, but exactly there is a confusion like which have to like yes or no, in this one. So we have to give the answer in yes or no. So I'm getting a confusion in that one. So which one I have to yes and which have to I have to no. You
Okay.
can
Okay.
accept.
Yeah.
Yes.
Ma'am, activity 11.5, question number 2, 5 and 6. Two.
Activity 11.5, question number 2.
5 and 6.
Okay. All right. Any other topic you want?
Once can you explain this p-value thing? This is
Yeah, p-values there. Any other topic? Okay.
Emma, can you please brief on the topic of posterior mode and posterior mean?
Posterior mode and posterior mean. Okay. Okay. So I will start from week 8 then, and we'll move accordingly. Okay.
Ma'am, one small note.
Yeah.
Ma'am, when you will discuss model estimation and that main important topic for intern.
Model estimation. Yeah, right. So
As you said,
important topics for end term has already been announced, right? Mostly it's estimation and hypothesis testing.
yes, ma'am,
So,
that you said as first in video, you will discuss that too in this video, in this session.
sorry.
As you mentioned in the starting of this session, you will also explain that estimation and the important thing.
I mean, not the important thing. I mean, I will go to the whatever the doubts you have in estimation, hypothesis thing. I will take those doubts. Okay.
Okay.
All right.
And just one request, ma'am, that if you will be able to cover it sharply by 7, so that we may attend our next class of mathematics as well, which will be starting from 7 p.m.
Yes, right.
Yeah. Okay. Thank you.
Thank you. Also, the formula file for final quiz has been uploaded on the portal. So just please check. Okay. And the mock is scheduled tomorrow from 7 to 8. There's a time mock. You must have received the announcement for that.
Ma'am, Andrew's session will be
It's on Monday only.
for week 10 and 11.
Not sure, but hypothesis testing is there. be possible Bayesian estimation part can also be there.
Do we have any other sessions other than this one and Andrew's session?
Yeah, it's next week. That will be scheduled.
Okay, thank you.
All right, so we'll start with estimator. Okay. So somebody had asked about variance of estimator. Correct? So let's say I have a population and it has a parameter, let's say theta. Theta is our parameter of the population. And I want to estimate this parameter. Let's say that estimator is theta hat. That estimate this parameter theta. So this is our estimated theta hat for the parameter theta. And it is, so you had asked about the variance of the estimator. Now let's say we have, let's say, n samples, x1, x2 up to xn, and they are coming from let's say a Bernoulli p distribution. If I take one of the estimated theta hat to be sample mean, so it is going to be x1 plus x2 plus xn by n. So if I have to find the variance of this estimator, so what is your estimator? Estimator is nothing but your random variable. It is a function of random variable. Now you have n random variables here, and this theta hat, that is sample mean, it is nothing but actually a function of the random variable. And if I have to find the variance of random variable, x1 to xn by n, so if I have to find this, so you see that n is our constant, we can take it out. So it will become 1 upon n square, variance of x1 plus up to xn. So if all these random variable were IID, I would have written 1 upon n square, variance of x1 plus up to variance of xn. Okay. And if all those were IIDs, like it is going to be n times variance of x upon n square. So variance of estimator is nothing but whatever estimator you have. In this case, if our estimator was a sample mean, I try to find the variance of the sample mean. It is nothing else. So I think you must be asking this problem from quiz 2 problem, is it?
Yes, ma'am. Actually, I got the answer right in the quiz too, but I forgot how we actually arrived at the answer. So I wanted to know, like, how would it work? Like, I want to know the basic how the thing works.
So if you had gotten the answer right, I think this is the way you must have solved. I mean, the estimator is given to.
Yeah, ma'am. This is the way I solved it, but I don't know how I solved this way. Like, I want to know the bias. I guess I was asking about the bias of the.
Okay, so if we have to find the bias, what do we do? If I have to find the bias of an estimator, let's say, so what do you find? We find expected value of theta hat minus theta, right? And this is nothing but expected value of theta hat minus expected value of theta. Since theta is a constant, it is again going to be just theta. So theta hat is our estimator, and it is again a function of a random variable. The same way you can find the expected value of theta hat, and this is theta. So if it becomes 0, right? If bias becomes 0, we say our estimator is unbiased, right? But if it is not 0, we say our estimator is biased. That is the only thing we do when we have to check for biasness. Or if we have to find the bias, we try to find expected value of theta hat minus theta. So whatever value you get there, if you get 0, you say it is unbiased. And if you get some other value, we say it is biased estimator.
All right, ma'am. We'll take the samples and we'll pass it through the estimator and you will check
Yeah.
the. Okay, thank you.
Yeah. Okay. So also in estimated part, like you should also know how to find the method of moment estimate, maximum likelihood estimate. In quiz 2, we saw like many people have answered it wrong. So is like, do you have doubt in method of moment estimate and maximum likelihood estimation?
Possible, you can explain it again.
Yeah, okay. So so there are in week 8 and week 9, right? So we are talking about design of estimators, and there are 3 different like 2 different approaches of design of estimator. So design of estimators, and there are like 2 different approaches. One is frequentist approach and other is Bayesian approach. Okay? So in frequentist approach, what we say is like our parameter theta is a fixed constant. Okay, in frequentist approach, we say our parameter theta is a fixed constant, right? We assume that it is a fixed constant. But in Bayesian approach, we say it is a random variable. In Bayesian approach, our parameter is a random variable. So that is the only difference in frequentist and Bayesian approach. So in frequentist approach, we have 2 different methods that we have studied in week 8. One is method of moment that we call as MME, and other is maximum likelihood estimator. Okay. So what we do in MME is like I will take the same problem from quiz 2 and I will solve that. Okay. All right. So we had a random variable there. We have a random variable x, and its distribution was given to us, right? So we had a distribution of x. So you have a random variable x, its distribution, you have fx, and x was taking the values 0, 1, 2, and 3. And the probability that x takes the value 0 is theta by 2. The probability that x takes the value 1 is 1 minus theta by 2. This was theta by 2, and again it was 1 minus theta by 2. So if I have to find the method of moment estimator for theta, so theta was given to be a line between 0 to 1, right? Because this is these are probabilities and it should lie between 0 to 1. Now, if I have to find the method of moment estimate, what is the first step that we do here there? So the first step that we find is expected value of x. Okay. So what is expected value of x? So this is the distribution that is given to us, and from there I will try to find expectation. So 0 times theta by 2 is again 0, and 1 times 1 minus theta by 2, that is going to be 1 minus theta by 2, plus 2 times theta by 2, plus 3 times 1 minus theta by 2. So if you solve this, you will get this is theta minus theta by 2 minus 3 theta by 2 plus 3 by 2 plus 1 by 2, right? So this is how much? This is minus 4 theta by 2, so minus 2 theta, and 4 by 2. So this is 2 minus theta, right? Yeah. So this is the expected value of x that we got. Now, if we have observed few samples, let's say I have observed x1, x2 up to xn, okay? So we substitute this expected value of x from m1, right? So what is m1? m1 was nothing but the sample mean. So m1 was sample mean. So I will just substitute this expected value of x by sample mean. So x1 plus x2 plus up to xn by n equals 2 minus theta. Now from there, so the sample was already given to us. We'll find the sample mean from there, and then we find the theta. So whatever theta we get, that we call as, this is an estimator for the parameter theta. Okay, so this is the process that we generally use for finding the method for finding the estimator using method of moments. And the next is the maximum likelihood estimator. So what we generally do, so in maximum likelihood estimator is, we first define the likelihood function. So if we have a sample x1 to xn and we have a parameter data, we define the likelihood function, that is x1 to xn, and it is given by product of all the samples that we have observed. So it is fx of xi, where I is varying from 1 to 1, and the parameter is theta. So let's say if our samples x1 to xn, if it follows geometric p distribution, okay, let's say all the samples are IID geometric p. So what is probability x equal k? It is 1 minus p.
All power k.
Yeah.
K minus 1. Yeah. To p.
Okay. Yeah. Sure. So even this was a problem in your quiz 2 paper, right? Where you had a situation given to you and you had to identify what distribution it is. There also we saw many people have done it wrong. So was there a problem in identifying the distribution there?
Yes.
All right. So what is generally the geometric distribution? Like where you observe the first success, right? Like if you are interested in getting, let's say the first head, and if I keep tossing the coin and the trial at which I obtain my first head, I will say like such kind of situation models the geometric distribution. It means if I observe my first head on the kth trial, right? So the first k minus 1 at trial, I have my tail, right? And on the kth trial, I have my head. So such kind of situation models your geometric distribution. So once you had figured it out what the distribution there is, I hope it would have been easier. Okay, so whenever we have to find the likelihood estimator, so first we define the likelihood function. And if I say the samples are following the geometric distribution, so we first write what is the distribution. So in this case, the distribution is 1 minus p to the power k minus 1 into p, right? So if I take the product of this, so I have n samples. I have n samples, and the product is going to be 1 minus p x1 minus 1 p 1 minus p x2 minus 1 p up to 1 minus p xn minus 1 p, right? And 1 minus, you can take all these things common, so p to the power n, and 1 minus p, this is going to be sum over xi, I varying from 1 to n minus of n. This is my likelihood function now. Okay, this is a likelihood function for the sample. So once you obtain your likelihood function, the second step that you go to is you can do the log likelihood. Okay, and so if you take the log on both the side, log of L, you will get n log p plus sum over xi minus n log 1 minus p. After you find the log likelihood function, you try to differentiate it with respect to your parameter. So in this case, my parameter is p. So I will try to differentiate this log likelihood function with respect to the parameter p. So it becomes n upon p plus sum over xi minus n divided by log of, so it is 1 minus p, and again you have minus 1 outside. So after this, we want to find our p, right? We want to find the estimated p hat. So in order to do that, we will equate this to 0. So if I do that, we will get n upon p equals sum over xi minus n upon 1 minus p. So once you solve it, so if you solve it, you will get n minus np equals p times sum over xi minus np, and your p becomes reciprocal of the sample mean. So it is n upon sum over xi. So this becomes the estimator for your parameter e. So this is the general approach that you always use to find the likelihood function. So first you define what is your likelihood function, then you take the log likelihood, then you differentiate your log likelihood function with respect to the parameter, and then equate it to 0 to find the estimator. So in the previous problem, if we had some sample given to us, so let's say if the sample given to us was these are the samples, like the samples can only take the value from 0, 1, 2, 3, right? So let's say I have observed the sample 1, 2, 1, 3, and 0. This is what I have observed. So if I have to find the maximum likelihood estimate for these samples, so what I will do is I will first write the likelihood function, right? And how do you write the likelihood function? So what is the distribution of 1? It is 1 minus theta by 2, right? So 1 minus theta by 2, and it is coming 2 times. So I will just square it. Then 2 is, the distribution of 2 is theta by 2. So theta by 2. And distribution of 3 is again 1 minus theta by 2. So I can write the cube here. And 0 is again theta by 2. So I can do the square here. Now, since this is like, if you take the log likelihood and you differentiate it, all this constant term will vanish, right? So I can ignore this and I can just write L is proportional to theta square 1 minus theta cube, right? So we have already found the likelihood function. Then I will take the log likelihood, and then I will differentiate our log likelihood with respect to the parameter theta, and then substitute it to 0, and we will get our estimate for likelihood
I
log line.
think
Yeah.
from my end, I did mistake here. Like I understood like this. Okay, if and only if it is geometric Bernoulli or binomial distribution. So I thought like that. Now it is clear. Distribution can be like this. I can express.
Yeah. So if the distribution is given,
Nikita, just a question over here. The likelihood function that has come, which is written just below the line. Does
in
it?
this page, yes, this one, right? Yeah.
Yes, right. So does it have some significance, or is it just an intermediary step in order to calculate the estimator? I mean, what is it that we can derive by looking at the likelihood function? What does it say? P raised to power n 1 minus p summation of this thing.
This is basically like the distribution that your random variable has, right? I have just written, this is given by the product of the.
Yeah, I mean, it's coming. It's coming from the multiplication. I understood that as a process that you multiply and then you will get. But does it have some significance? For example, we will multiply 2 times 2 raised to power 8. We understand that it is 2 raised to power 8, right? It has some value. So similarly, does this signify something in the real world, or should we consider just to be an intermediary step as a part of the process to calculate the estimator? Should we just limit ourselves to that?
Okay, so also from likelihood, from this, I can talk about also the distribution of likelihood.
Distribution of the likelihood.
Like
Okay.
when you go to the Bayesian estimation part, there, what do we say? We say prior is, we get some posterior density, right?
Right.
So we get some posterior density. So in this case, I am getting, this is of the form.
Yeah, this is one of the part of
To the
it.
power
Right.
n 1 minus x to the power something, right?
Hmm.
And I know such kind of distribution, that is x to the power alpha 1 minus x to the power alpha minus 1 minus x to the power beta minus 1, right?
Hmm.
So I know this is, if I have observed something like this, I know this is a beta distribution. I can say that.
Hmm.
So here also I can say that like this likelihood function
Okay.
that we have
I see.
observed
Fine.
is from the beta distribution. So all this observation we can derive from there. We can just look at the likelihood function.
I see. Okay.
Yeah.
Excuse me, ma'am.
Yeah.
Ma'am, the geometric distribution you have written in p x equals to k 1 minus p to the power k minus 1 into p. This means 1 minus p is the probability of failure, and we have failed k minus 1
K
times
minus 1 times, and we
Yeah.
have observed the success on kth time.
Kth time, yeah. Ma'am, but in one question I got in tutorial 2 of week 9, I've got question number 6. Here we have written as p to the power n minus 1 into 1 minus p to the power 1. The reverse thing.
Okay. Oh, wait, can you tell me the question number again?
Yeah, ma'am, it's tutorial 2 of week 9, question number 6.
Question number 6, wait.
Ma'am, can I read out a question for you?
I'm just looking at it. Wait.
Okay, okay.
Total 2. This problem, Rohan wants to do a survey in his hometown. Is this a problem? Hello, can you hear me?
Yes.
Okay. I'm not sure who had asked the question, but are you there?
Yes, sir. Yes, sorry. Yes, ma'am.
Yeah. So, is it the problem? Rohan wants to do a survey.
Yes, sir. Yes, ma'am. Sorry. That's the question.
Okay. So, It says Rohan wants to do survey in his hometown on vaccination. He decides that as soon as he finds the first person who is not vaccinated, he will end the survey. So again, it is a geometric distribution, correct? So in this case, our success is the finding the person who is not vaccinated. So the number of files on which you find the person is not vaccinated, that is the first success, correct? So if let's say I select I chose one person and ask whether the person is vaccinated or not, and it says the person is vaccinated. So it means it is a failure, correct? Again, if I find a person and the person is not vaccinated, a person is vaccinated, again it is a failure. And the moment I find that the person is not vaccinated, I will stop, and that is going to be my success. So before it starts a survey, he knows that the probability of a person being vaccinated has a prior distribution of beta, alpha, comma, beta with an expected value of 0.6. And the fifth person is surveyed is found to be not vaccinated. Find the estimate of a probability of person being vaccinated in terms of beta. Yes, so what is the doubt here?
Ma'am, I think the success is here whether the person is vaccinated. The person is vaccinated is the success here. So P should be this thing, but we are taking the reverse thing. We are taking success as the person is not vaccinated.
Yes, we are taking the success as the person is not vaccinated.
Yeah, but ma'am, we want to find the estimate for a probability a person being vaccinated in terms of beta. So this must be a thing we should take as success, no?
Okay. About a person being vaccinated in terms of beta. Yeah, you can take that also.
Ma'am, but the probability, the PMF thing is written in reverse order. P to the power
Right.
n minus 1. This creates confusion here.
I think there's some mistake in the solution here. I
Ma'am,
mean,
actually one more question I found the same thing. P to the power n minus 1.
P to the power n minus 1. Okay. So
And this thing means that success is n minus 1 times, and failure is the nth time. This is the reverse thing that
no. So in your success should have been the moment you observe that the person is not vaccinated is success. So that should be RP in this case. It is written wrong here actually.
I have seen some few more questions like here.
Can you tell me the question number?
I don't remember it now. I have to search for it. But one or two more questions I've found like in the similar way the formula is being written.
Okay.
So Nikita, alongside, can we, I
Wait.
mean, can we expect something around the unusual distributions which we have seen in the course, but I mean, not so many questions for practice, negative binomial, then we have something called the hypergeometric. Can we expect something, because in the formula file also those have not been uploaded, the formulas for the PDFs of hypergeometric or the negative binomial. Can we expect or can we
okay,
skip
these are not standard distribution basically. So
yeah, they are not standard. That is what I'm asking. I mean, can we expect
negative binomial is what it just fixed number of price how many successes you observe. So same hypergeometric, you have two different parameters and you want to.
Correct,
so these
right.
are not very standard. You'll have to, even if these distributions are not given to you, and you see the situation, you should be able to figure it out, like how the situation is modeled, and try to formulate the probability distribution there.
Okay, so it's not ruled out. I mean, it can be there, right? Yeah, fine.
Yeah.
Okay. Yeah. Thanks.
Ma'am, in question number 6, the answer is also matching with the correct answer with this formula p to the power n minus 1 minus p. So what should I do in these kind of scenarios if it happens?
Okay, so in this case, our success should have been the person being not vaccinated. and we have to the prior distribution is given for the person being vaccinated, right? That is beta alpha comma beta. So it is for 1 minus p. Okay. Something needs to be changed here. Okay, I will change this on the portal also. Some mistake there in the solution.
So ma'am, in exam we have to do the same thing which you just taught here, p to the power 1 and 1 minus p to the power n minus 1 thing.
Yeah.
Okay, ma'am.
Yeah. So you have to find out like what is your success, and accordingly you should define your p, and then find the
Ma'am,
distribution, find the
ma'am,
like. Yeah.
we can say like if we are sending in geometric p value, we can assume it is p into 1 minus p power n. If I am sending in geometric distribution, it is 1 minus p. It is 1 minus p into p power n minus 1. Is that like that?
Sorry, can you repeat?
Oh, okay. In geometric distribution, if I'm sending a value p, if it is a p, it is going to be 1 minus p power n minus 1 into p. If it is not the p, it is going to be 1 minus, if it is, I'm sending 1 minus p in the geometric distribution, it is going to be 1 minus p power n minus 1 into p. That might be the
It
scenario.
is then going to be p to the power n minus 1 times 1 minus p.
Yeah, that's what I'm trying to say.
Yeah, right.
That might,
This is what it is going to be.
okay. In this case, maybe it might be, I didn't see the question. Maybe it might be the reason in solution. I'm just guessing.
Okay, let me see. P to the power n minus 1. Oh, yes, that is right. Yeah. Yeah, thanks for that. So here P is the probability that a person is vaccinated. Okay. Now this makes sense. Yeah, this is correct.
Ma'am, can you explain me once more this thing? I didn't get it.
Yeah, wait. So there, I'm saying that on the 5th trial, I found that the person is not vaccinated. So first trial is vaccinated, second vaccinated, and it is not vaccinated. And it models the geometric distribution. It models the geometric distribution with the probability. So if this is, let's say, if P is the vaccinated, probability the person is vaccinated, 1 minus P is going to be the probability that the person is not vaccinated. In this case, our success is defined as the person who is not vaccinated. So I will take my parameter here to be 1 minus P. Okay. So,
okay, ma'am, I understood this thing, ma'am, because in geometric we stopped doing the we stopped looking for the further things when we got success, and for here we are stopped looking the further people when we got for someone who is not vaccinated.
Yes,
that's okay. And ma'am, one more thing, ma'am, in some questions we are using the formula directly, like if the distribution of some random variable is given, suppose it's exponential, and the prior is also given as gamma, alpha, beta, then we have the direct formula we are using in some of the questions, like n plus alpha and beta plus x1 to x1 plus up to xn. So are these formula be given to us in the question?
no, these formula will not. So you can check the formula file that is uploaded on the portal. So these are not given to you. So what you have to take care of, like let's say if I'm saying my random variable x is exponential lambda, and my prior is given to be, let's say, gamma with the parameter a comma b. And if I have to find the posterior density of the parameter lambda, I will do prior times likelihood, correct? And in case of gamma distribution, you will have to, distribution of gamma will be given to you in the formula sheet. Distribution of exponential will be given to you in the formula. So you will have to use those distributions to find the posterior. So in case of gamma, the distribution looks something like x to the power alpha minus 1 e to the power minus beta x, right? Gamma exponential distribution looks something like lambda e to the power minus lambda x. So if I want to find the posterior density of lambda, it is going to be proportional to prior times likelihood. So the distribution of prior is x to the power alpha minus 1 e to the minus beta x. So what I will write is, I will write lambda times lambda to the power a minus 1 and e to the power minus beta minus b lambda. And what is likelihood? So likelihood is a sample that you had observed there. So it is going to be product of lambda e to the power minus lambda xi, where I is varying from 1 to n. And from there, so let's say if I have observed n samples, x1 to xn, that follows exponential lambda distribution. So I will write it lambda to the power a minus 1 e to the power minus beta lambda, product of all these samples, all these likelihood if I write, I will get lambda to the power n e to the power minus lambda sum over xi, right? Varying from 1 to n.
Nikita, in this question, is it not x supposed to be a random variable in prior that you have written x raised to power alpha 1? I mean, I understand this particular thing.
Okay, yes.
Gamma distribution x raised to power
X is
alpha
a
minus
random
1
variable.
e raised to power minus beta x, right?
X is a random
So,
variable.
yeah, but in while calculating the posterior density, we have taken, instead of x, we have taken lambda.
So, okay, so in Bayesian approach, as I had said, that the parameter is nothing but a random variable. We consider the parameter as a random variable. In frequentist approach, we say our parameter is unknown but a fixed constant. So if it was not a Bayesian approach, I would have said this parameter lambda that we have, that is unknown to us. It is still unknown, but it is some constant. But in case of Bayesian approach, what we say is lambda is unknown to us, but it is a random variable. This is the difference between the frequentist and Bayesian approach.
I see. Okay.
So since lambda is a random variable here, I can write this. So all these, yeah. So if x has if x has some distribution, if your prior has some distribution, then posterior distribution will not be given to you. You will have to figure it out on your own. By you should know the method. If you know the method.
Yeah, I mean, you did say that particular thing, but now I can get the context what you actually meant.
Yeah.
Okay, fine.
Yeah. So if I try to write it, I will get lambda to the power a plus n minus 1 e to the power minus lambda b plus sum over xi, correct? And again, if you see it, it is nothing but a gamma distribution. It looks like a gamma distribution where the parameter a is going to be
a plus n,
and the parameter beta is going to be b plus sum over xi. So you will have to figure out the distribution.
Okay, ma'am.
Okay, so somebody has raised hand. AP, right? Do you have doubt?
Good afternoon, ma'am. Ma'am, actually, my doubt is not related to syllabus. It's kind of related to the quiz 2 marks, I think. So
Okay.
is that permissible?
Okay, please, sir. Yeah.
Ma'am, actually, I just wanted to clarify something. It's just that, well, I've been, I've checked my answer transcript with the, answer key which you guys provided in the dashboard,
Okay.
right?
Mm-hmm.
Well, there was this particular question which had, the options question, the optional question which had those, in which we had to enter the option numbers in the comma separated format, right? Right. So I think it was a comprehension question 17 and 18. Right. So, ma'am, I had, the first question I answered correctly, right? But the second
Weak law of
question.
large number and CLT.
Yes, ma'am.
Okay.
Yes,
So why it is not given to you? You have answered correctly weak law of large number.
Yes.
So the comprehension question was for if you answer both wrong, you will get those marks. But you had already answered weak law of large number, and from there you have already got 3 marks.
Right.
So that is why, like, even though your CLT part was wrong, like this comprehension question was not being considered because you have already gotten 3 marks from there.
Right.
So even even for the step marks question, it was the maximum marks you would have gotten if you have like answered both wrong, you would have gotten 3 marks. Okay, but you have
Is that so?
already, yeah, 3 or some
Right.
2 marks, 2 or 3.
Right, ma'am, because the CLT one was a 4-mark question, and that's the
Yes,
only thing
right.
which I got wrong.
Yeah, I got it. Like this, because if you that is for both. If both of them goes wrong, then that would have been considered. But you had already answered. If you would have answered, let's say CLT part correct, and you would have gotten 4 marks, then still this would not be having considered.
Right, but if it had been considered, then I'd be only getting 3 marks.
2 or 3 marks, whatever it was. Yeah.
Right. Right. Okay. Okay. That's all I think. Thank you.
Thank you. All right. So, any other doubt in finding the posterior? So, like, this is the usual approach that we follow. You should you have some samples. You know what is the distribution of the samples. You know the prior of like what is the prior distribution of the parameter, and once you know that, you should be able to find the posterior that is given by prior times likelihood. You just try to solve it and try like just see what distribution it matches. Okay, so like this is a usual general approach. You should know this. Any doubt in this part? Okay, we'll move forward then. So the next part that somebody had asked was model estimation. So again, model estimation is something of this kind. Like you have some information that you know, and from there you want to like see what like what distribution does it model. So the same as what we had seen here, right? So the parameter, like the samples
Nikita,
models.
if you can
Yeah.
take it with some question, maybe the examples that professor has taken or a question from the tutorial.
Okay, let's check. So I will go with the same problem that professor had taken. Okay. So one of the problem, it says in a new machine, suppose that out of 10 produced item, no item was found to be defective. Okay, so you have 10 items here and there are no items that you found to be defective. How will you estimate the fraction of defective items produced by the new machine? From data collected from other similar machine, the average of the fraction of defective item was found to be 10%, and the actual fraction was between 5% and 15% in 95% of the cases. So here it says that you have a machine, and from there you have taken 10 objects. So let's say I am denoting it by x1 to x10. And each of these xi, they are IID Bernoulli, right? Bernoulli, let's say P. Now, each of the items I take, either it can be defective or non-defective. But what I have observed, like I have taken 10 items from the machine, and one item I picked and check whether it is defective or not. Other item check defective or not. So what we have observed is from these 10 items, none of them are defective. So all of them are non-defective, right? So how will in such a case, like it is very difficult to estimate what is P. So what I do is like I take some different samples from the same kind of machine. Okay? So if this is just one kind of machine from where I have taken 10 samples, so here I have observed all the non-defective items. But now I am taking some samples from the similar kind of machine, and what I have observed is I have observed that the fraction of defective item is 10%. Okay, so if I take some from different, let's say from different machine M2, and I found the fraction of defective item, like probability of defective item, it is 10%. So 0.10. Now, how will you find like how will you estimate this fraction, right? So what has been done in the problem is, let's say from my prior knowledge, I know that this fraction models the beta distribution with the parameter A and B. Okay, so in this
How?
case, it is just
What clues did you take from the question that you were reached to
no.
that you were?
It is like from in the question, it is not given to you. Like if you look at the lecture, like it's not that something is given in the problem. It's like I'm just saying, let's say this is what I have observed. Let's say I assume that the prior distribution of P is following some beta distribution. It is not given in the problem statement here. If you go look at the lecture, it has been told that let's say, like just assume it, like from the prior knowledge that I know that this models the beta distribution. You must have seen in many lecture, like practice question and practice assignment or grid assignment, right?
I am not
Something
able
like
to
this.
relate prior. I mean,
Okay.
how we
Okay.
assume this prior beta AB.
No, this is just I am assuming, like this is my prior knowledge. I mean, I cannot say that it is nowhere given in the problem, in the problem statement. This is just my assumption. I mean, in real life, how will you just do it? So if some question like that comes, it is always given to you. Okay, so in the problems that you must have seen in the practice assignment or graded assignment or also tutorials, you must have seen that in such kind of situations, we have given some prior, let's say we know this follows gamma distribution or the beta distribution, something.
Yeah, exactly. I mean, those kind of questions are there where we are
So,
finding either the posterior mean or the posterior
yes,
density.
yes.
That
So
explicit
there also
information is there prior,
yeah,
right?
here also explicit information is given. It is not given in the problem statement. If you go back to the lecture and say it, right, you will see it has been said that from my prior knowledge, let's say I know it is not written in the problem statement.
No, what do you mean prior knowledge? I mean your prior knowledge of knowing statistics, or what do you mean when you say your prior knowledge? I mean, if this
My
question
prior,
is given, how will I solve it? If I do not have any prior knowledge, what do you
so
what is
it
it that
won't
should
be
I
given.
take?
It won't be given like that in the problem.
Then
That's
how
what
will I solve this question is what I'm trying to understand. You are saying prior
it
is
will be
beta
written
AB.
it will be written in the problem statement. That is what I'm trying to say. If it comes in the problem, it will be written in the problem statement that this is your prior knowledge about the parameter. I will take one example from your practice assignment. So
So this comes comes under which week? Which week?
9th week. It is a 9th week. Okay, so if you look at 10th, I will share the screen. Wait. Just see here. So it says assume that the time elapses from one call to the next at a 911 call center has the exponential distribution with parameter lambda. Okay, and your prior belief about lambda is that it is a mean 3.5 and standard deviation 1. So here it has been explicitly mentioned in the problem that this is your prior belief, right? It just there in the lecture, it is not written. It has been just said and solved. But if it comes to you to solve a problem, it will be always written in the statement that this is a prior belief. Are you getting it?
Yeah, I'm trying to get it.
Like,
So
it's not like you will be just given something and you will have to like choose some prior and solve it. It won't be like that. I mean, this part over here that your prior belief about this, it's not like it won't be given to you in the problem statement. It will be given to you in the problem statement, because unless it is given, like, it is difficult to come to a particular answer, right? If I am asking you, if I'm giving you any problem, so unless I give you what is the prior distribution, it is not possible to come at a single answer. And these are like textbook kind of problems, right?
Yes, I think. Yeah, if they didn't give any prior belief, we might
You may
understand it
some,
might be
you
different
may choose
distributions.
some different,
Yeah.
like you have some
Yeah.
data, you may think, okay, this may follow this distribution, and they will go through it. But every people may have different prior belief and they will come to a different answer, right? But if such kind of problem comes in your exams or something, like the prior belief will be given to you, like what is the distribution of the parameter. If it is not given, it is not possible to come to a single answer.
yeah, so Nikita, in the problem 2 that you were trying to solve, my question was,
that's what
I mean, you are saying that prior is beta.
Yeah, so see, if I just look at the problem statement, it nowhere says that what is
My question was,
prior.
what are you trying to read so that you reach to
Yeah, it is not
this particular thing?
it is not
I
mentioned.
got what I'm trying to understand.
Yeah, I got what you're trying to
Okay.
understand. So what you're saying is, if I just look at the problem statement, how can I find the fraction of defective items, right? So it is like not possible just given this problem statement and you will come to a single answer. It is not possible. So while solving this problem, what sir did is, like, he took a prior, he just believed like that, let's say it is follows the beta AB prior. Okay. It must have also been written in the problem statement. Okay. If it has been written in the problem statement, you would have using the beta like beta prior and then solved it, right? But in this case, was not written, so we just assumed it. Okay.
So can I take any prior?
You cannot. No, I mean, you should have some knowledge about it is not a real life statement. It is textbook kind of problem.
Okay,
right?
fine.
I mean, if it comes in your paper or some like assignments, it will be always given to you what is your prior.
Fine. Okay.
Okay.
Okay. You might
But
want to
in
go proceed.
real life,
Thanks.
yeah. Okay. All right. So mostly, so any other doubt from the estimation part? If not, I can go back to, I can go to the hypothesis testing. Okay, I will move to the hypothesis testing part, or before that, if there was any problem, I can just have a look. So,
Have you covered the posterior mode, and which is written on the
okay, yes,
right side?
posterior mode, thanks. So,
Ma'am, after posterior mode, can we discuss the p-value?
yeah, after this, I will go to hypothesis testing.
Okay.
So, once we find the posterior density, right, we like the estimation is can be written as either posterior mode or posterior mean. So, what is mode in general? So mode is like whatever occurs the maximum number of times in your sample. We just generally call it. It is the mode of the sample, right? And mean, for mean, you just generally you consider all the samples and just sum it out, and we say this is our mean. So posterior mode, there are two different estimators there. So one is posterior mean, posterior mode, and the other is posterior mean. So in case of posterior mode, what we do is we just check. Let's say if I have a parameter, if you have parameter p, and I am saying the parameter p has is taking two values. Let's say p1 and p2, and they have some distribution. Let's say probability of like p1, this p1 has let's say 0.4, and probability of occurring of p2 is let's say 0.6. Okay, so if I have two different estimators for p, one is p1, other is p2, we'll have to check which one will give you the maximum probability. So in order to do that, we will have to find probability of p1 given the samples and probability of p2 given the samples. So whichever comes the maximum, if this is bigger, we will say our p1 is the posterior mode. If this is bigger, I will say this is the posterior mode. Okay, this is just one method to find the estimate of your estimator, estimate of the parameter. In case of posterior mean, what we do is we find the posterior distribution. We know, let's say the posterior follows the gamma distribution with the parameter AB. And then to find the posterior mean, we can just find the mean of this gamma distribution, that is A upon B. And this is one estimate. This is just one estimate of your P here, we'll say. So just two different methods to find the estimate. One is mode and one is mean. There is also something posterior median that we have not seen in this course. Okay. So it's just two different methods. So generally, if we give to find the posterior, like the Bayesian estimate, you try to find the posterior mean. It's like it's a better because in this way we considered all the like estimators estimates we have, and just sum it over. It gives a good estimate. Posterior mean gives a good estimate. So we generally consider this. Is it okay?
Hello, ma'am.
Yes.
Ma'am, since the posterior density is not given in the formula sheet and we have to figure out by the likelihood into prior. So what about the posterior mean? Because some of them are really big formulas.
So for normal, it is already given. So I
Okay.
say the normal is difficult to remember and difficult to derive. So it has been provided in the formula sheet. But the
Okay.
rest you can easily find out.
Yeah, rest is okay. I was only concerned about the normal
Yeah,
one.
so yeah, no, that is provided in the formula file. You just go and check on the portal. It is already uploaded.
Yeah, okay. Sorry, ma'am.
Yeah. Right. Week 9 tutorial 2 feedback. Oh, okay. We have discussed this, right? Or we have not?
No, ma'am. I have a question there. Like, could you please go there?
Yeah, just wait. Yeah. So, can you tell me where is the problem?
Yes, ma'am. There the distribution of the prior is a uniform distribution, right? That fraction, maximum four.
So you have problem in like why is it given?
Yes, no, ma'am. My problem is that while calculating that likelihood function, why the PMF of that, the PDF of the prior is 0.66. Like it shouldn't it be like uniform 0A, that PDF would be 1 by A minus 0. Shouldn't it be like that? Why it is 0.66 written in the calculation of
Posterior is
like
likelihood times prior, right? Then you have likelihood. Okay, yes, there is a mistake there, but anyways, this is just a constant and it will be ignored later.
Okay, okay.
Yeah, it should be 1 upon 0.
No, yeah.
Okay. Yeah.
Thank you, ma'am.
Thank you. Okay. We'll go back to week 10 and we have p value. Yeah. Ten point 10.6 question number 3. 10.6 question 3. You have p value.
Can you explain how for some questions the alternate hypothesis is taken differently? So, will you explain something on that as well?
Which problem you're talking about?
On general, I'm asking how to.
Yeah. I will.
Yeah.
Okay. Okay, so generally how we take the null hypothesis and alternative hypothesis as, so H naught is generally what we believe to be always true. Okay, so and HA is like what we try to claim. So if I say let's say okay, let's say there is a problem statement that say the average marks scored by students of a school in the board exams is reported to be 400. Okay, so this is what is given to you. This is what we know has happened. Okay, so we'll take this statement that is h naught, that is mu equals 400. This is considered as true. But what you suspect is the average may be lower. So this is what you want to check, that is the average lower than what is what is given to us. So if
Actually, that's not the question.
no, I was
It's a coin question.
no, I was trying to explain the null and alternative hypothesis.
Okay, this is an example you have taken.
Yeah, right. So if I say, if the statement is given to you that the average marks obtained is 100, so this has been given to us. So this way we assume to be true. Let's say it is true. So what I will say is my null hypothesis is mu equals 100. But what you want to check, you suspect that the average is lower and you want to check whether it is lower or not. So you will take your alternative hypothesis to be, let's say mu is less than 100, and at some significance level you want to check whether you will accept your null hypothesis or you will reject your null hypothesis. So generally the null hypothesis that you take is the simple hypothesis, and the alternative is composite, or it can be simple both. Okay, so this is just one example that I have taken here.
Yeah, so for this example, we should consider the test as the x bar should be less than some c. Right?
X bar should be less than some critical value, right?
So if this satisfies, we'll reject h naught. If the calculated critical value is less
greater than
yeah, c is
then
less than x bar, then what
we'll accept, we cannot reject the null hypothesis, so we'll believe that the null is true.
Okay, so I'm asking the other way. If x bar
yeah,
is
if x bar
greater
is less, if x bar is less than c, I say I am rejecting h naught.
Okay.
But if x bar comes out to be greater than c, I cannot reject h naught. Cannot reject h naught. So if I cannot reject h naught, I will have to accept h naught. It means we don't have sufficient information to reject h naught.
Okay.
I will just accept my h naught. Whatever is given, I will just accept that it is true.
Okay. Okay.
Okay. I had the same question. Like whenever we have something like if we are checking for a critical value, it is not equal to or greater than, just the reverse we have to accept, right? If it is a reverse, we have to accept. Sometimes it can be equal to also same value. Okay.
Yes.
Okay, ma'am. Thank you.
Ma'am, if suppose the significance level is given to be like 0.95, this means that we have 95% confidence that we are rejecting this hypothesis or accepting it.
Okay, so here you are taking like a very big rejection reason here. So if I'm saying 95% confidence, so we'll reject if x bar is less than c, and if that is 95%, so around this much of, I'm saying this is a level of significance that I'm giving. So whatever happens, you are mostly rejecting your hypothesis, right?
Ma'am, it means like if significance level is given like in 95%, the significance level is 0.95, then it means we have 95% confident now, like we have to reject this hypothesis or not.
Yeah,
This tells me the confidence level actually.
Yes, I mean 95% confident that you are rejecting the null hypothesis.
Okay, ma'am.
Yeah. Okay, so
rejecting the null hypothesis given
the null is true. Yes.
Yeah.
So even you know that the null hypothesis is true, and you have such a big level of significance that is 95%, you will end up rejecting the null hypothesis.
So in other words, we can say like there is only 5% probability that I will accept the null hypothesis given the null is true.
Yeah, right.
Yeah.
So the problem statement was 10.6. Yeah. You have a coin and you would like to check whether the coin is fair or biased. So P is the probability of heads and the null and alternative is given to you. Coin is tossed 100 times and we observe 55 heads. Okay. So H0 is P equals 0.5. Alternative is P is greater than 0.5 and you have tossed your coin 100 times and you have observed 55 heads. And what is P here? It is probability of occurrence of head, right? And we have to find the P value now. So if I have to find the P value now, so what is P value? It is the lowest level of significance at which you will reject your null hypothesis. So
one small doubt for the alternate hypothesis here, we can consider P is less than 0.5 also, right?
P is in this case?
Yeah.
Yes, we
yeah.
can consider that.
Yeah.
So, okay, we have tossed the coin 100 times and we have observed 55 heads. So, so it basically models a Bernoulli distribution. So let's say I have first toss, second toss, and up to I have tossed 100 times, and each of these are going to be IIT Bernoulli P. So I can take my test statistic. I can take my test statistic either to be, let's say, first time taking my test statistic to be x1 plus x2 up to x100. Okay, and what it will give? It will give total number of heads. So what we have observed our total number of heads, it is 55. So if I take my t to be x1 plus x2 plus x100, so if I have to find, let's say, alpha, so what will I write? I will write probability of rejecting my H0 given H0 was true. So H0 was true is P equals 0.5. So
Ma'am, what is the test statistic? What does this mean, and how we check that? How we take the test statistic here?
Yeah, so in this case, so what we have observed is you have tossed a coin 100 times and we have observed that we have got 55 heads. We have observed 55 heads, right? So I can take x1 to x10, a binomial NP, right?
Yes, ma'am.
Right, and the other thing I can take is I can also take x1 plus x2 up to x100 divided by n. Divided by 100. This also I can take my t as. So whatever t you take, if I take t to be x1 to x100, in that case, so you are rejecting h0 if t is greater than some c. Correct? So given p equals a 0.5. So this t is a binomial distribution. T follows the binomial distribution with n equals 100 and p equals 0.5. So what is the, if I have to normalize this, so what will I do? I will subtract this t from the mean of t and divide by standard deviation of t, right? So what is the mean of t?
50.
50, right? So I will say t minus 50, and what is the standard deviation?
NP into 1 minus P.
So
P into
0.5 by
0.25. Yeah.
Yeah, sorry, just 0.25. If
0.25 into 100, right?
Yeah, 100, right? So it is going to be your 5.
5.
So it is going to be your 5. So this is again C minus 50 by 5. So this becomes your Z. So it will be probability Z greater than C minus 50 upon 5. Right? And this is nothing but 1 minus FC C minus 50 upon 5. This is our alpha significance level. But we have to find the p-value. That is the lowest significance level at which you will reject your null hypothesis. So the same way we have found our alpha, what we will just do is, in place of C, so this is the critical value, but I'm saying we have observed 55 hits, right? So in place of C, I will just write 55. So if I do that, I will get 1 minus MC of 1. This will give you the p-value.
To generalize this, we can say like replace C with the given
Yeah,
X
replace
bar.
C with the
Yeah.
given whatever you have observed, the the sample mean or whatever.
After when we found the alpha, what you did next for the p-value, I didn't understand this thing.
Yeah, so what I was trying to say is the way you find your significance level. So this is the way you find, like, a significance level is probability that reject H0 given your null is true. Correct. So p-value is nothing but significance level. It is the lowest significance level at which you will reject the null hypothesis. So you have performed an experiment, you have some samples, and whatever you have observed from there, you will just substitute that. So in this case, I had 100 samples, and from there I had observed 55 heads. So I will just substitute this 55 heads over C. So this critical value here becomes 55. That is total number of heads.
Just I think I did not follow properly. In your solution, when you're finding the alpha, you said probability of t greater than c, given probability is of the heads is 0.5. How would you say t minus 50 by 5? I didn't understand that.
T minus 50 by 5.
5.
Okay,
Yeah.
this part.
Yes.
So so I had taken my t to be x1 plus x2 plus up to x100, right? And this models my binomial distribution with n100 and p 0.5, correct? So my alpha is that you reject H0 given H0 is true, right? So I am rejecting H0 if t is greater than the critical value. Now, to solve this, I will have to convert this test statistic to the normal distribution, normal Z, normal 0, 1, right? So how can you do that? I will have to find the mean of t. What is the mean of t? It is NP, that is 50. And then I will have to divide by standard deviation.
Yes.
So that is under root of 25, that is 5. Same thing I have done here. So it becomes MC of
Standard deviation, how did you get 5?
Sorry?
Standard deviation, how did you get 5?
Standard deviation is what? So you will have to find the variance of t, right? So variance of t is what? It is NPQ. So 100 times 0.5 into 0.5. So it is what? 25. So what is the standard deviation? 5.
Okay.
Was that problem clear?
Yes, ma'am. Yes, ma'am. Thank you.
Okay. Yeah.
Ma'am, a small query regarding the quiz marks, ma'am. Can I ask you now?
Yeah, sure.
Ma'am, like whether it has been awarded out of 100 or out of 50, ma'am. The marks which are displayed in the dashboard.
This is out of 100, right?
100.
Yeah.
Thank you.
Yeah.
Ma'am,
Yeah.
is G test and F test are important? Are there in for NTEM and syllabus like?
Yeah, tests are important. So in the previous week, I had discussed the z-test p-value in detail. Can you just go back and have a look over it? I will
Previous
do the
quiz, ma'am.
problem. Not the previous quiz, previous week, previous Saturday, last Saturday.
Session. Okay. Okay.
Last, the p-value, z-test, the whole hypothesis testing part, I have discussed there.
Okay, ma'am. Thank you, ma'am. I will go
I'll
through
just
it.
take the problems from here.
Yeah.
Last week was very useful for me, ma'am. Thank you so much. I was able to do the graded assignment.
Yeah, thank you. So, 10.7 I will check now, okay?
Ma'am, can I ask a question?
Yeah.
Ma'am, during the hypothesis testing problems, the type of test like chi-square or t-type or z-test, will they be specifically mentioned in the question, or we have to assume from the type of data given?
Like you will have to figure out on your own, like what kind of test you are going to use. Like we have different ways, right? Like if you have a simple z-test, so there you test for mean, right? So test for mean, you have two tests. One is z-test and other is t-test. Right? So when do we use the z-test? When we also know when the variance is known to you. When do I use the t-test? When the variance is not known to
And
us.
the population variance, right?
Yes, population variance. Right? These are tests for mean. Then you have two samples z-test. It is same as z-test, but just you have two samples here. Same process, what you use for z-test. Then you have test for variance. You have test for variance, where one is your chi-square test, and other you have is f-test that you use for two sample test. So whenever in the problem statement it says you want to test, you want to check the variance or something, then you use chi-square or f-test depending on how many samples do you have. And whenever you want to look for the means, like you want to test for the means, either it can be z-test or t-test. So you will have to read the problem statement carefully and try to figure out on your own like what kind of test you are going to use.
Ma'am, I think I should also mention this. Sometimes in the last quiz 2 questions, we had multiple values given in the beginning, like hint. It was given as hint. It doesn't mean that all these values will be used in the problem, right?
Yeah, doesn't mean that.
So similarly for this also, I think they are going to provide us, since there are multiple tests, they are going to provide us what will be the f inverse of some chi-square or f of t to confuse us basically, I think. So we have to be very careful in finding out what test we are going to use.
Yeah, you will have to figure out it.
I'm sure they're going to confuse us. Yes, thank you.
I have a doubt on the F test, actually test for variance. So in test for variance, we'll consider sx square by sy square is either greater than or less than some 1 minus 1. Yeah.
Yes,
How
yes.
to?
I will come to it. So I will just finish that test.
Okay.
And
Thank
I will come to chi-square test. So 10.7, question number 3 and 4.
Excuse me, ma'am.
Yeah.
Ma'am, I've got this question 3 and 4, so you can skip the question if you like.
Okay, sure. Thank you. Anybody else has doubt in solving the z-test? I mean, problems from z-test? Okay, so if nobody has the problem, we can go to week 11 part. So, okay. Practice assignment, question number 2 and 7. Okay. So in question number 2, it says one wants to check if the average IQ of girls and boys are the same. Okay. It is known that IQs of both boys and girls have a standard deviation of 10. Mean IQ of 200 randomly selected boys is 99 and mean IQ of 300 randomly selected girls is 97. You have to use 1% level of significance to comment on the IQ of girls and boys. So, can you mute this? Please mute.
ना मेरे टी-शर्ट देख लियो
Please, who's there?
हाँ बस
Yeah. So, in problem number 2, what it says is you want to check whether the IQ of boys and girls are same. It was average IQ. Yeah. Also, it is given to us that the standard deviation of IQ of boys, is 10, and same the standard deviation of IQ of girls is given to be 10. Now we have taken some sample, and from there we have found that for 200 randomly selected boys, it is 99. And from 300 randomly selected girls, it is 97. So in order to check the statement, whether the average IQ of boys and girls are same or not, what we did is we took 2 samples. So from one sample, which is, let's say, N1 equals 200. So let's say for boys, I'm representing by X, and for girls, I'm representing by Y. So NX, it means total number of boys that had been taken out for like checking the average IQ. We found that it is given as 99. And we have taken a sample of 300 girls and found the IQ to be 97. Okay. We have to use level of significance to be at level of significance to be 1%, that is 0.01. Whether I will conclude to that the IQ boys and girls are same or whether it is different. So let us say that I define my null hypothesis to be that okay, so the first question that I will ask here is, what kind of test are you going to use here?
So we can
Sample test.
That test.
Null hypothesis mu1 equal to mu2.
Yeah. So here we know that we want to check it is a test for mean basically. So it can be either Z test or T test, right? And here we have 2 different sample, one for boys and one for girls. So it is a 2 sample Z test. Why? Because the standard deviation, population standard deviation is also given to us, that is 10. So it is, we are going to use 2 sample Z test. Here. So 2 sample Z test. Now, what is the null hypothesis we can take? It is mu x equal mu y, and alternative is mu x not equal mu y. Okay. If
or
I have to,
here itself we can take mod of t should be is greater than c. Can we consider that as alternate?
Sorry, mod
of t.
Mod of x bar minus y bar. I think that's what.
Yeah. Mod of x bar minus y bar is greater than c.
Yes.
We consider... Nikita, this is the graded assignment question that you have taken, right?
Practice assignment.
No, this is the graded assignment question 1. I had the doubt from practice assignment 1, question 2. I mean, if you're taking someone else's doubt, doubt is fine. Then my doubt was from practice assignment question 2. This is not the practice assignment question.
taken from practice. Let me just check once. Week 11. Okay, yes, it's a different problem.
Yeah. So
It
my
was a third problem in practice assignment. Like what I was doing as the third problem from practice assignment.
as my assumption is correct. My point. Mod of x bar minus y bar. Can we
Yeah.
consider this as alternate hypothesis?
This as alternative hypothesis. No, like why to take this as an alternative hypothesis?
Okay, alternate hypothesis should be in terms of the population, right?
Population.
Mu x, yeah, okay.
Yeah.
Okay.
The sample has been just taken to check.
Yeah, got it.
So anybody has doubt in this? Right of the wrong problem, actually.
No, ma'am.
No, like everything is clear how to do a 2 samples at test.
Yeah.
Okay, then we can skip this part. So, practice assignment question number 3.
Nikita, practice assignment question number 2.
All right, sorry. A random sample of 40 fibers.
Yes, right. So, I mean, you don't have to go through all the steps. The solution is there.
Yeah.
My specific doubt is in the solution, if we say it's given minus 1.96.
Minus 1.96.
Yeah, the FZ value, the inverse of FZ of 0.025 has been calculated as minus 1.96.
Yes. Yeah, what is the
And
doubt?
that is where I'm finding a bit of challenge. Now in the question, FZ inverse of 0.025 is nowhere mentioned. If you can see the practice assignment 11 that we have got the FZ values, FZ inverse of 0.025 has nowhere been mentioned in the options. Would that be the case in the upcoming quiz also? And then perhaps
in quizzes, in quizzes it is not going to happen.
And is my reading right? I mean, I'm trying to understand minus 1.96, how minus 1.96 has been derived in this question.
Okay, so what you can do is, so we had minus 0.05 by 2 FC of something. Okay, now it is minus C of something. Okay, and this is minus 0.025. So basically it is going to be FC inverse of 0.025 C upon something.
Right.
Now in the problem, what is like whatever is given, the values as in the paper.
So FZ
of
1.96
is 0.975.
Exactly, right.
So that is what?
Yeah, I mean, that is what I wanted to check. We have, instead of 0.025, we have taken the negative portion and then we have come to conclusion of minus 1.96.
Yeah, because for minus, like for 0.025, right? For 0.975 area, you will get this as 1.96. So FC of 1.96, it covers the area of 0.975. Okay. But if you take minus 1.96, it covers the area of 0.025. This is 0.025.
Okay, because of the symmetry property of
the symmetric property. So even if you know just one value, so if at 1.96 it is 0.975, so at minus 1.96 it is just going to be 1 minus. We know this then, right? That FC of minus A is nothing but 1 minus FC of A. Right? So if I, let's say, if this is my A, this is my minus A, and if I have to find FC of minus A, okay? So FC of minus A area is same as this area, correct? This area is going to be same as this area, tail. These two tail areas should be same. And this area you can find using 1 minus FC of A, because FC of A will give you this whole area, correct? And if you do 1 minus the total minus this area, you will get this tail area, and this tail area is going to be same as this tail area. So you can also remember this part to avoid the confusion.
But
no, in the problems, it
in
should
the
be,
upcoming
yeah,
assessment, that would not be the case to interpret even
no.
this level of detail, right?
It will be given to you. All those things will be given to you.
Fine. Next, in the same practice assignment question 7.
Ma'am, in this question, there isn't a solution. I think there is a calculation problem. Because in the practice assignment, we check the answer, so it is rejecting, and in solution, it is accepting the null hypothesis. So
we will not reject H0, okay?
But in the just the answer, you can check that it is saying that we have to reject the H0.
Yes, exactly, right.
Okay.
So I think it's a solution calculation problem, if I'm not wrong.
Oh, okay, maybe.
In the assessment, it has been marked wrongly.
Yeah, that's the thing.
The correct solution is what is written. We will not reject H0.
So whatever the solution is provided is right, or
yeah. In the assessment, maybe the program is not right. Nikita, same assignment, practice assignment 11, question number 7. Actually, the solution is not complete, and I got stuck at one of the points.
Which problem?
Question number 7.
Question number 7. Okay. Company manufacture mobile. This problem. Mobile chargers, right? Seven, 8. What is not complete here?
The feedback given is not complete.
Okay. So it says the company manufactures mobile chargers. So the parents take a random sample of 12 chargers. All right. Okay, yes, right. So for this, it is check H0, right? Yeah. Okay. So what is happening there is that it is not completed there. So we had observed our test statistic value to be something 2.58 or something, and the chi-square value. So draw the graph of this. So for some 0.05, you have for 0.05, it is happening at some 4.57. So this is my rejection area. And what I have observed is some 2.58. So that lies in the rejection area. So we can just say we are rejecting H0.
Can you explain it again? Like,
Yeah. So if you look at the graph of this, you have a two-sided chi-square test. So at some 4.57, you have the 5% level of significance here. So 0.05. That's 2.28. Okay, so let me just see what is the value for 0.025. Can somebody check the value for 0.025 chi-square?
Degrees of freedom?
Degrees of freedom 11.
.82.
3.82. Okay.
So actually this was causing the problem. We were supposed to take 0.025,
Yeah.
and in the solution it has been just
To the
stopped at
0.05.
0.05 equals to 4.57. What to do after that?
Yeah, that is where it went wrong. Right. So basically at 3.82, I have like this 2.5 level of significance, and whatever I have observed is
But
some
why will it be
0.28 value.
0.025? I mean,
Yeah,
this
because
has, it should be 0.05, right?
But
this is coming basis after taking the calculation. Should a significance level should not be 0.05?
it is a two-sided test. So
Okay.
basically we go by alpha by 2 there. So if you take alpha by 2, it is at 3.82, you are getting some 2.5% level of significance. So this 2.28 will also lie in the rejection region, right? Because at 3.82, it is 0.025 a level of significance. Then at 2.28 will also lie in the rejection region, and we will say that we are rejecting our null hypothesis.
Nikita, can you explain in that theoretical way, not by graphical way? Not very comfortable actually with this particular approach. So maybe if that test statistics is greater than the calculated value, can you explain it in that way? It will be a bit easier to understand for me at least.
Right.
Is this F test?
No, this is a chi-square test. We have just one sample.
Okay.
Our H0 is sigma square equals some sigma naught square, and alternative to be sigma square, let's say, to be greater than sigma naught, sorry, not equal to sigma naught square. And the test statistic that we take as Sx square
is 2.28. We can calculate that thing at least. I mean, that calculation we can skip.
Yeah, that is fine. And we know that n minus 1 s square upon sigma square follows the chi-square distribution with degrees of freedom n minus 1. So the test we can take is reject h naught if s square is greater than some 1 plus CR or 1 minus CL again in this case also. So
typically for one sample, we'll consider C square, right?
Yeah, so 1 plus CR is not the case in chi-square at least.
Yeah.
Yeah, it has not been given. Like we have only studied like one-sided test.
Yeah.
In chi-square.
Right.
So that is why I was going through the graphical approach.
1 plus CR comes in F test.
Yeah, that is right.
Yeah, so for in the syllabus, do we have two-sided chi-square test as well?
No, that is not there. Actually.
Okay, then this question is out of syllabus.
Two-sided chi-square. It has not been taught in the lecture also.
That has been the problem with the whole course, in fact.
No, I mean most of the things are taught in the lecture, right?
Hope they don't ask this question in the
I
final
haven't
exam.
gone through this question exactly. Whether in that question it is given that it is two-sided test or how.
That has been the case. We are spending so much time in order to understand something that has been explained. What is it coming from? Where is it coming from? Why is it coming from? And then we realize perhaps it is not required to be completed.
Maybe, ma'am, it is in additional lecture. So that is not in our syllabus. So that's why we will stuck on the same question.
No, in additional lecture, it is only good fit
chi-square
test.
test for independence and good test. Yes, right.
Should not be a part of this practice assignment within that particular course than what we are supposed to practice.
In stats, so everything is possible.
Okay, so for now we can maybe skip this part and just look for the F test. So for chi-square, just look for one-sided chi-square test. Basically, that has been taught in the lectures. And for F test, you have all the one-sided.
How to differentiate one-sided or two-sided? It will be given in the question, or we have to.
Yes, right. So somewhere it will be given, like wait. So in the problem statement itself, if you read it, you will understand whether it is one-sided or two-sided. So if it is written something like whether the mean is same or different, so in that case you are assuming that your null hypothesis is mean is same and the alternative is mean is different, that is not equal to. Okay. So
Nikita, for the two-sided test in the formula file, it clearly mentions the not equal to part of alternate hypothesis. And it is considering that particular thing, but not with 1 plus CR. It is going ahead with only the test statistic and the C value, not with 1 plus CL or 1 minus CL.
Just let me check it.
So if that is the case, then definitely this becomes a part of our syllabus. That is not like outside the course then.
Just wait. Yeah, so it is like it is given that you can check any one tail. So what I was doing in the graph part, so I had taken the left tail and checking whether you will reject the null hypothesis or not.
Yeah, the concept is fine, but you were using 1 plus and 1 minus, right?
Right, exactly.
Yeah.
That's what
That is
created the
not required.
confusion.
Yeah,
Yeah,
because
That's what created the
that is wrong.
confusion.
Yeah,
yeah,
right.
the factor 1 arrives
Yeah,
from
arrives
S1 square by the
yeah,
ratio of,
yeah, right.
I remember that one was mentioned in the lecture itself.
Yes, that at one, yes, right.
So in this case, this is covered under the syllabus, right?
Yeah, like the problem has not been done, but this part has like it is mentioned in the lecture. I mean, for right tail test and left tail test, we have seen the problem, but we haven't seen.
So Nikita, net, if we take the value of 0.05 by 2 of
Yeah.
chi-square inverse, right? And
Yeah.
then we just need to compare 2.28 with this particular 0.025 chi-square. And then if it is less, we reject or accept, whatever is the scenario.
Yes.
That is what needs to be done, right?
Yeah, so if I've taken the like alpha by 2, that is coming at 3.82. So
And
this becomes
and the test statistic, I mean, the test statistic is
this value.
2.28, which is less than 3.8.
Yes.
Right?
Yeah. That is right. So that lies in the rejection reason. So we are saying that we are rejecting the null hypothesis.
Fine.
So like this reason, right? This shape, this blue reason here, this is a rejection reason. So this lies at, this is at 3.82. Okay, this point is 3.82. And this observed test statistic value is at 2.28. So it is somewhere less than 3.82. Correct? It is somewhere 2.28, right? Which is less than 3.82. So we are just rejecting the null hypothesis.
Okay. Next, graded assignment question 3 from week 11.
Yeah.
And what I want to specifically ask over there, I was struggling to solve it with 1 minus CL condition. If it has to be solved with 1 plus CL only, 1 plus CR only, why so? And if it can be solved with both, then you might want to explain how we have been able to solve with 1 minus CL condition, 1 minus CL situation.
Problem number 3, right?
Problem number 3, graded assignment 11.
Yeah, okay. Okay, so all those who have to leave for Maths 2 session, you can leave.
Ma'am, in the same question, I have a problem like here it is taking alpha. And in the you can see, and in the practice assignment, question number 3, I think. So they are taking alpha by 2, and the formula is also the alpha by 2 is equal to that 1 plus here, whatever. So why here it is taking alpha, and in that question, in the practice assignment, taking alpha by 2.
So in practice assignment, why it is taking alpha by 2? Because it is, it has the null hypothesis is not equal to. Over here, it is greater than or lesser than thing. That's where it is just taking
No,
not
in the
divisible
both the
by 2.
question, if you like see the Andrew said session, like in 11.4, I think, lecture. So in both the cases, like 1 plus CR or 1 minus CR or 1 plus CR. So both the cases, they are taking 1 minus alpha by 2, and in second is alpha by 2. So that's a thing I'm confused. You can check 11.4 lecture, and there is 2 things, just I
So
thought.
no, it is like if either of one satisfies, you can just confirm whether you are accepting the null or rejecting the null.
Sorry,
Like
ma'am, can you repeat it?
if any one of it satisfies,
Yeah.
So trying to say is like if your sx square or divided by sy square, if this is greater than like 1 plus CL, sorry, 1 minus CL, or SS square by SY square is less than.
I think the other way.
Yeah, it is other way. Sorry, it is greater than 1 plus CR. If any one of it satisfies, we will say we are rejecting the null or accepting the null. Like no need to check for both the cases.
No, if any of this satisfies, we'll reject null, right?
For two-sided test, yes. For two-sided test, and there we take alpha by 2. Like if you have two-sided test.
Nikita, is it greater than lesser than 1 plus CL, or just lesser or greater than 1? That is what we need to identify, right? I mean, if Sx square upon Sy square
Ma'am,
is lesser than 1.
By standard deviation, if we divide both these, so if it is like 1 less than 1, so we can.
I will just go from starting here.
Yeah, sure.
Confusion, yeah. So, like, if my null hypothesis is sigma 1 equals sigma 2, and alternative hypothesis is, let's say, sigma 1 greater than sigma 2. Okay. So this is my again one-sided F test. I am taking my test statistic T to be S1 square by S2 square. All right. So what is S1 square by S2 square going to be? So I will say my test is reject H0 if S1 square by S2 square. So these S1 square, S2 square values will be given to you in the problem statement, right? So if this comes out, to be, let's say, less than 1, if it comes out to be less than 1, okay, so you will say you are rejecting H0 if S1 square by S2 square is less than 1 minus CL. Okay, so this is our test, reject H0 if S1 square by S2 square is less than 1 minus CL. Now, if my alternative is sigma 1 less than sigma 2, and if I take the same test statistic to be S1 square by S2 square, in this case, it is going to be greater than 1. Sorry, again, it is less than 1, right? So, test statistic, if I take here S2 square by S1 square, now it is greater than 1. Like looking at the values, like whatever you have in the samples, If it is greater than 1, we take test to be reject H0 if Sx squared by S2 squared by S1 square is greater than 1 plus CR. So basically you have to check your alternative hypothesis. So in this case, your sigma 2, you have to check whether sigma 2 is greater than sigma 1. All right. So I will take my test statistic to be S2 squared by S1 squared. In this case, my sigma 1 was greater than sigma 2.
Yeah, are you sure about the formula?
Going
Yes.
wrong. Yeah.
Yeah, because one side you are mentioning S1 squared by S2 squared. On the other side you are
Something is going wrong. Yeah.
Yeah.
So in this, again, in this case, it is S2 squared by S1 squared is going to be less than 1.
Yeah, the main understanding is which one is more, S1 is more
Yeah,
or S2 is more. That
S2
is
is
what the
more.
concept is.
Yeah,
Yeah.
yeah, right. So once you figure that out, you can take like any of the tests that you want.
So Nikita, just to simplify this particular thing, if the alternate hypothesis, the first scenario that you have taken, if we take the alternate hypothesis as sigma 1 lesser than sigma 2, then the test statistic will be S1 upon S2. I mean, this is a bit difficult to remember. And this is the first time that we are seeing in the discourse, everything has been discussed in a different way.
Let's take the example. It will be, I think, more clear.
In the discourse, you had mentioned S1 upon S2 square.
Let's take the example. It will be better.
Andrew sir also same Sx square upon Sy square mentioned in the lecture. So that's a confusing one here.
Yeah, let's take the example.
Actually, it doesn't mean what
So
we are
please take the
considering.
same example. Question number 3 of graded assignment.
Yeah, just let me go there. Let me go there. Okay, so share this screen here. So the problem says an ITM instructor conducts 2 live sessions for 2 different classes, call it A and B. Section A had 25 students and section B had 36 students. Although there was no significant difference, section A has a standard deviation of 10 and section B has a standard deviation of 14. Can we conclude at 0.01 level of significance that the variability in class of marks of class B is greater than that of A? So the null hypothesis is sigma 1 equal to sigma 2 and alternative is sigma 1 less than sigma 2. Okay, because we have to check whether the variability in marks of class B. So if I take this as 2 and this as 1, so this is what we have to check. Now, these are the standard deviation that has been observed. So for class 1, it is 10 and for class 2, it is 14. Okay, so I will take, if I take my test statistic to be, let's say S1 square upon S2 square. Okay. Let's say I'm taking my S2 square by S1 square. So if you do it, it should be like greater than. So
This is
sigma
something
2,
new. We have not gone through this.
Ma'am,
But
like we
this is the
cannot
first
take
time that we are
S1.
seeing this S2 upon S1.
Yeah,
S2 upon S1. Okay, let's go by S1 upon S2 then. Okay.
yeah.
So S1 upon S2, right? If you do this, it should be, just look over here. So sigma 1 less than sigma 2. So what I will do is I will take my test to be like test statistic to be S1 square upon S2 square. Okay, let's say this is the test statistic that I am taking, and I will say this follows the F distribution with degrees of freedom. So how many elements you have in one? It is 25. So 25 minus 1, that is 24, and 36 minus 1, that is 35. So this follows our F distribution with degrees of freedom for 24, 24 and 35. Now our test says that you reject H0 if if S1 square upon S2 square is less than 1 minus CL. Okay. So why I wrote less than 1 minus CL is because see, sigma 1 upon sigma 2 is going to be less than 1, right? So I can just write reject H0 if S1 square by S2 square is less than 1 minus CL. Now if I use if I find my alpha, it will be what? Reject H0 if your test statistic is less than 1 minus CL. So test statistic S1 square upon S2 square is less than 1 minus CL given my null is true. So sigma 1 equals sigma 2. Right. And this is following F2435 distribution. So this is basically F2435 distribution with 1 minus CL. And if your alpha is given, so in this case, your alpha was given to be 1%, so 0.01. So we have to find F inverse of F of 2435, 0.01 equals 1 minus CL. So whatever this value you get, you just check with 1 minus CL. So what is the value we'll get here? Can somebody check?
Okay, so I'm not very sure. F inverse F24, 35 is same as F inverse F of 34, 35, 24?
No, it is not same.
So then it is not given. This value is not given in the question.
I'm only given is 0.99, I think, if I'm right.
35, 24 is given.
Okay.
Yeah, so ma'am, in this
that is
question,
what I was asking. I mean, if I have to solve with 1 minus CL, how will I solve it?
Yeah, so no, this value should be given in the problem.
So ma'am, like in this question, like whatever the, just sir or you solve that one in the practice one. So we are deciding according to that, like it is given in the last one, we can see that find the level of significance that the variability in marks class B is greater than that of A. So we have to find B is greater than A. So that's why we are taking S2 square upon S1 square according to that.
So you can take either S1 square upon S2 square or S2 square upon S1 square, it doesn't matter.
Okay.
You can take any test statistic. That is what I was trying to say. So as you saw in the like assignment solution that has been uploaded, there it has been taken as S2 square upon S1 square, right? And still we got, so the only thing that is going to change here is your F value is going to change. So if I write S2 square by S1 square, it means now I will have to consider this thing. I mean, what is the degree of freedom for S2? So it is it is going to be 36 minus 1, that is 35, 24. So if I take my test statistic to be S2 square by S1 square, this will follow the distribution F for degrees of freedom 35 and 24. But if
Nikita, what we understood, what have we been seeing in the lectures and whatever questions we have been putting on discourse and the answers we are getting, we understood that if S1 square upon S2 square is less than 1, then we should take the value of 1 minus CL to be tested.
Yes,
when we are testing 1 minus CL to be tested, there wasn't any option to find the F inverse value.
Yeah,
and that is where we got stuck.
Yeah, so you know how to find the values, right? You can always go to the online calculator, or you can write a code and just find
But
the
exactly the problem in exams, so that's
no in exams it will be provided to you, like exams, all the
in the
values
starting
that
I
is
solved
needed.
the same way, whatever you solved that, like F inverse 2435.
So all these assignment you are not doing like in the examination hall. Like if something is missing, you can always go look online or find it on your own and then come to the answer. But in exam you cannot do that. So we always provide you all the possible values that is required. So
yeah, ma'am. One thing, just I asked it in the starting that alpha by 2 and alpha. So can you explain that one?
So so what I was trying to say is, like, you can take any test statistic. You can take either S1 square upon S2 square, or you can also take S2 square by S1 square. It doesn't matter. You just have to like take your F to be proper, like degrees of freedom to be proper. If you are taking S1 square by S2 square,
No, ma'am. Oh, that not thing I'm asking. I'm asking.
No, I just summarizing it up. Okay, you can take any test statistic value. That is not the case, but you will have to design your test accordingly. So like if I have taken here that S1 square upon S2 square should be if I check S1 square by S2 square, so in this case I know that it is going to be less than 1. So I can design my test to be like reject H0 if S1 square by S2 square is less than 1 minus CL. But in case if I would have taken S2 square by S2 square, S1 square as my test statistic, then in that case, I would have rejected H0 if S2 square upon S1 square comes out to be greater than 1 plus CR.
Yeah.
Okay. So both ways are possible. It's just what is the test statistic that you take and how accordingly you design your test. Like you will get the same answer.
We can solve it with these two methods. Like we can solve with this.
Yeah, you try any problem you take and try to solve it using both the test statistic. You will get the same answer.
Okay, like but the condition is we have to take less than 1 minus CL, and if it are taking S2 square upon SN square,
if
then
this is greater, you will have to take greater than 1 plus CL.
Okay, got it, ma'am.
Now, if I come at two-sided test, then in that case, what happens is
I hope in the upcoming quiz it would not be that we have to solve it in the way that you guys want to solve, right? If in these scenarios where both these scenarios are possible, it should be the option also that we can choose the correct answer and come to the conclusion.
Yes, right. So this was just the assignment A, like some values have been missing from the.
But ma'am, exactly what happens, ma'am, we solve all the assignments, so it's a confusing, like the exam is coming different way, and the practice and we are doing the different way, so it's a lot of confusion because there is so many concepts in the we have to study. So
exactly, and lectures itself are so confusing to understand.
Yeah, I understand.
Half of the steps are not told, and they have been said to just assume yourself whatever you want to assume with those steps. So it's quite frustrating, to be honest.
I don't know if it has been done very often. I'm not sure about it.
No, lectures are fine. That's a good, just I understand that one. But exactly what happens when we are coming to the practice assignment?
There are different ways to like solve it. That is right. But all the values that are needed, like if you go through a particular method, like the values will be given to you in this exam. That is all I'm trying to say here. So don't worry about that you're going to some other way and we cannot.
The last thing, just whatever the question will come in the final exam. So, just give it according to the lecture. So we can do that. That's the thing. The
the final exam.
Yeah, thank you.
So in two-sided test, like your sigma 1 equal to sigma 2 and the alternative is sigma 1 not equal to sigma 2. So what we say is like you can reject your H0 if this is 1 minus CL. if it was just one-sided test, right? If it was just one-sided test, then this is your alpha. Okay. So let's say I am taking the first case here, reject H naught of S1 square upon S2 square is less than 1 minus CL. So what would my alpha be? So okay.
Ma'am, you can take the question number like 4 in the practice assignment, and in like you can take in graded assignment question number 3. So both these like in one thing there is an alpha, and in one thing is alpha by 2. So with these two examples you can explain.
No, see, if I am saying that my test, there it is. So reject H naught of S1 square upon S2 square is less than 1 minus CL. Okay. So this is
Excuse
my
me,
alpha.
ma'am.
This is my alpha. Just please hold on. This is my alpha. Okay.
Yes, sir.
But if I say reject H naught of S2 square by S1 square is greater than 1 plus CR. Right. So in this case, this is my alpha. But if I have a two-sided test, so I have combining these two, I have alpha. Okay. So what we do here is like we say this is alpha by 2 and this is alpha by 2.
Okay, so in a simple way, if it is like less than or greater than, then we take alpha, and if it is like two-sided, then we take alpha by 2.
Alpha
Simple.
by 2. And if like if you take your test statistic to be S1 square upon S2 square, right? So if the test is like reject H naught, if S1 square upon S2 square is less than 1 minus alpha L, so you find this as alpha by 2 level of significance. So whatever conclusion you get from there, like if it comes in the rejection reason or acceptance reason, so you try for both the tests, like S1 square by S2 square, try for both. If any of it, one of it validates, then you can reach the conclusion. So yeah, just give me a question number for the two-sided test. Can you give me a question for two-sided test?
Ma'am, that question number 4, I think, if I'm not wrong. Yeah, question number 4 in practice assignment.
Excuse me, ma'am.
Yeah, please, sir.
Ma'am, are we going to discuss the activity 11.5 also after this, or you'll end up the session after this?
Okay, we can just quickly go through it. Okay. After this, I will take the question.
Okay, okay, ma'am.
So practice assignment problem number 4.
Question number 4.
Okay.
And in solution, it is given question number 8. You can check.
Right. Okay. So if I'm taking SA square upon SP square to be greater than 1 plus CR, or SA square upon SP square to be less than 1 minus CL, right? So if I can take test for any one of it and I can just reach to my conclusion. So like if should I open just the solution and discuss?
Yeah, sure, no problem.
Okay. So over here, like we have a two-sided F test, and I am taking my test statistic in this case to be SA square upon SP square.
Yes.
So I am saying to check H naught if either SA square upon SP square is greater than 1 plus CR, or reject H naught if it is less than 1 minus CL. Okay. Anything you can take. Now for A, degree of freedom, like degree of freedom for both of it, it is I think 10.
That is.
So degree of freedom is going to be 9.
9. Yeah.
So SS square upon SP square follows F9, 9. Now I can take any one of it. So here we have taken the second one, that is SS square upon SP square less than 1 minus CL. So that is alpha by 2 is probability S square upon SP square less than 1 minus CL. Given H naught is 2. We have obtained 1 minus CL to be 0.248. And if you substitute it, like if we find S square upon SP square from the samples, you found that it is equal to be 0.820, which is far greater than 1 minus CL.
Yes.
Correct? So we can not reject our H naught. So we will accept H naught. Now, if you go for 1 plus CR, right?
Yes.
So if so, in that case, it will be the test is alpha by 2 is probability S square upon SP square greater than 1 plus CR. In that case, you reject your H naught. And again, the same thing will happen. So it will be just 1 minus F99 1 plus CR. And you will take a value and find the value, find 1 plus CR. So whatever 1 plus CR you are getting, on the basis of that, you will check whether it is greater than SS square upon SP square or not. If it happens, you will reject H naught. If it doesn't happen, we'll accept H naught. So if you try to solve, like find it, you will see that it won't come as greater than 1 plus CR. It will come as less than 1 plus CR, 1 plus. Okay. So in that.
So like, ma'am, in a simple way, we can say we take the SA square upon SB square, and if it is like given that both the values is given, divide it, and if it is greater than 1, so we take 1 plus CR, and if it is less than, so we'll take 1 minus CR. That's a final thing. Am I right?
Yeah.
Okay, got it. Thank you. Okay.
So great. The next was can you tell me the activity 11.7?
Ma'am, it was a activity 11.5.
Sorry, okay, 5. Tell me the question number.
Question number 2.
Okay.
Ma'am,
So,
yes, ma'am. If you can just solve in front of me this question, then I'll be able to predict what's going on.
Okay. Right. So it says you have a random variable X that follows the normal distribution with mean mu and variance sigma square, and sigma is unknown. And for 36 high ID sample, the observed sample mean is 15.5 and sample standard deviation is 3. What conclusion would a t-test reach if the null hypothesis assumes mu equals 14 against an alternative hypothesis that mu not equals to 14 at a significance level of 0.05? Okay.
Yes, ma'am.
So this is a t-test that is given to you. Now 0.05, the test is reject H naught. Test is reject H naught. Given mu naught is true, so given mu equals 14.
Nikita, sorry to interrupt. The previous question was F test, what we were solving, right? F test for two variants.
F test for
right?
two variants.
Yeah. Okay.
This is t test. This is t test. Now we have to check whether we will accept the null hypothesis or we will reject the null hypothesis. So what is the test that we are going to take here? Test is reject H naught.
Mod of X naught minus mu is greater than C.
Mod of
X bar minus mu
is greater than C, right? So probability that
So is
mod
this
of,
test given in the question itself, or
no, it is not given in the question. So X bar has been observed. It is given.
okay.
Whenever it's like that, mu is not equals to something, some constant, then we have to take this kind of.
Yeah.
Okay. So X bar minus mu greater than C. So greater than C given mu equals 14. Now I will just substitute my mu to be 14 here and say greater than C, right? Now, what is the standard deviation of X bar? That is not given to us. So what we do in place of it is we use the sample standard deviation, right? And what is the standard deviation of X bar? What is the standard deviation of X bar?
Sigma square upon n. Sigma upon root n.
Sigma upon root n. So
but sigma is not given here.
Sigma is not given. So I will use our sample standard deviation.
Okay.
Okay. So this is going to be X bar minus 14 upon sigma, S upon root n. This is greater than C upon S upon root n. Okay. So what we can write this as, this is basically our T, right? So this is T distribution. So this is T, and degrees of freedom is 35 because we had n sample, that is 36. So this is T 35 and it is greater than C upon S upon root n. Just try.
Ma'am, I found my mistake here. What I was doing, I was in the RHS side, I was doing C minus 14 also.
Okay.
I think that's what the problem comes in solution. And now one more question from this activity is question number 6. If you can just solve in front of me.
Okay. 6. Okay, this is 2 samples, right? So you have X to be normal mu1 4, Y to be normal mu2 25. You have 20 ID samples from X, 10 ID samples from Y. So the stage of mu1 equals mu2. You should have told me previously, right? Like when we were doing 2 samples at test. I think I was doing some problem. Yeah. So it is nothing but something similar to this. Can you tell me?
Actually, I'm having problem in like calculating the proper answer. I'm not getting it. If you can just solve in front of me, then
I will take the same because everything have been written here. So I will just take this, use the same method. So okay. So alpha is what? Okay. First, I will take my test statistic. So test statistic, let's say I'm taking X bar minus 5 bar, and I'm taking my test to be reject H naught if mod of X bar minus 5 bar is greater than C. Okay. So the alpha is going to be probability mod of X bar minus 5 bar greater than C given my null is true. Okay. So what is null? It is mu X equal mu Y. Right?
Yeah.
So I will have, now my random variable is X bar minus 5 bar. Right? So how will you find the expectation? In order to do, if you have to do the normalization of X bar minus 5 bar, you will find the expectation of X bar
expectation of X minus expectation of Y.
Right.
Which is mu1 minus mu2.
Mu1 minus mu2. So it becomes 0 because both are equal given null is true. Now the variance of X bar minus Y bar, it becomes variance of X bar plus variance of Y bar. Variance of X bar is sigma 1 square by n1 and variance of Y bar is sigma 2 square by n2. Right?
Variance of X plus variance of minus Y bar.
Yeah, plus variance of minus 5 bar. So minus 1 square will become plus.
Yeah.
Right? Now, okay. So this is, if I have to convert it to Z 0, 1 form, Z form. So I will do mod of X bar minus 5 bar minus 0 divided by under root of sigma 1 square by n1 plus sigma 2 square by n2. It is greater than c upon under root of sigma 1 square by n1 plus sigma 2 square by n2. Now this becomes our mod z. So
ma'am, how is this distribution be written? Like mod of x bar minus y bar will be written like normal of mu, comma, sigma 1 square by n1 plus sigma 2 square by n2.
Yes.
Ma'am, mu will be 0 here.
If your null is true, I mean if your mu1 equals mu2, then this is the distribution, right? If the null is true, this you have to take care of. Like it is 0 because your null was, we were assuming that the null was true.
Okay.
Right? So this becomes p equals alpha equals p of mod of z greater than c upon this part, and this is equal to 2 times probability z less than equal to minus c upon under root. Fine.
Yes, ma'am.
So this is 2 times fc of minus c upon under root. This will be your answer. Like this is going to be your alpha. And from then again you find, if the alpha is given, you find c and check whether you can reject your h0 or not.
Okay. Ma'am, one more question, one last question. This question number 7.
Okay. From activity, right?
Ma'am, from the same activity.
Okay, again it is two-sided F test. So can you tell me the problem here?
In F test, I am facing the problem in solving the question for F test.
Ma'am, one more thing in this question. So like we have to find out the value of P. After finding out the value of C, we have to put the value here and we will get the P value. Am I right?
Which problem?
In the same question. Like
seventh, is it?
Yeah. And that's particular slide you open that one. In the same question, the equation is 2fz knows minus c upon under root something that is.
Yeah,
so,
that is alpha.
Okay. Oh, thank you. So, ma'am, if everyone's doubt is clear, so just one thing, just I want to ask. So, can you let me know that there isn't confusion like when you have to find out the t and z and so can you explain that one, like when you find out the t?
I had gone through this part. Like if the test is for mean, it is z test or t test. Z test is if the variance is known, t test is if the variance is unknown. If the test is for variance, you have chi-square test and F test. If you have one sample, you will use chi-square. If you have two samples, you will use F test.
Okay.
That is the only thing that you have to remember.
Okay. And ma'am, can you open this activity 11.7?
Just hold on. Like I was discussing something.
Okay.
So this was 11.5, question number 7. So again, it is the same, nothing but the same thing, right? What we had discussed for 2 sample F test. So x has the normal mu1 sigma 1 square distribution, and y has the normal with mean mu2 variance sigma 2 square distribution. X and y are independent. Sx square is observed to be 16. Sy square is observed to be 17.5. And what conclusion would a F test reach if the null hypothesis suggesting? So if H0 is sigma 1 equals sigma 2, HA is sigma 1 not equal to sigma 2, you use alpha to be 0.05. And okay, so again, the same thing, you can either use like if my test statistic T is S1 square upon S2 square, either you can go through test is like either you can go through reject H0 if S1 square upon S2 square is less than 1 minus CL, or reject H0 if S1 square upon S2 square is greater than 1 plus CR. And to find combining both, it should be, since this is a two-sided test, combining these two, it should be alpha. So each one of them becomes alpha by 2. Okay. So whatever sample you have observed, so if I'm taking my test statistic to be S1 square upon S2 square, right? So just whatever you have observed your Sx square to be 16 and Sy square to be 17 by 5. If you do Sx square upon Sy square, you will get it to be less than 1. So I can just go through the first test, that is reject H0 if S1 square upon S2 square is less than 1 minus CL. So I can just say alpha upon 2 is equal to probability reject H0, that is S1 square upon S2 square is less than 1 minus CL, given H0 is true. And you can just solve it.
Okay, ma'am. Now I can solve this question.
Okay.
Thank you, ma'am.
So I think I've discussed almost like all the tests and different kind of problems from there.
Can you open it? Sorry, activity 11.7. There is nothing like calculation is needed. So there is something just I want to ask. Can you open it like?
Yeah, tell me the problem number.
Yeah, so exactly like ma'am in question number 3 and 4 and continuously like whole exercise. So how we decide that when we say no and when we say to yes, because all the question are about like a yes or no. So that's a confusion if you share this slide.
Nikita, can you explain how to take the alternate hypothesis for the word problems or the practical problems? Because I'm still confused. Or if you have explained this before in any of the live sessions.
The same live session and the previous live session also I had discussed.
Okay, of week 11.
Week 10, week 11, like in general hypothesis testing.
Okay, okay.
You can go through it and just check.
Yeah, thank you.
Yeah, tell me the problem number.
Ma'am, like 3 and 4. Can you share the slide like that?
Okay. Yeah.
Yeah. So like in this question, like ma'am, when we just I find out when we have to accept H0 and reject H0, but exactly at the end of that one, so I confused that when we have to accept yes and no. So that's the thing I'm asking. That's it.
Okay.
How to decide that we have to no say yes and no. That's the thing.
Okay. So here, what is your null hypothesis?
So in this one, so let me check.
Just look at the question and just read it out. You don't have to.
So like leave that one, just one thing, just like in this question, we have accepted H0, like in this one.
First, you see this question and tell me what will you take your null hypothesis.
I'm exactly yesterday I solved that one, so I don't know all the questions.
Like, it's not like if you have solved once, you cannot tell me like what can be the null alternative, right? I mean, every time you will get some different problems. You cannot just expect.
Yeah, that's a thing. No.
So just look over here and just try to understand like what is the null and what is the alternative here. If you have solved, you should know it.
Hello, ma'am.
Yeah, please wait for a minute.
Uh,
Please wait for a minute. Yeah. Yeah, can you tell me what is a null and what is alternative? Unless you understand what is null and what is alternative, it is difficult to reach to a conclusion. Are you there? I'm not sure who had asked this problem.
I'm sorry, ma'am, but I
Yes.
think he's not present here. So meanwhile, can I ask my doubt?
What is your doubt?
In week 10, graded assignment, question number 8. Can you
Oh,
go through it?
okay, so I've already gone through a lot of problems. Like if it is
Uh,
about
Ma'am,
some
it is a
yes.
conceptual doubt. I know there is solutions of that question, but
Okay, I will just go to the solution.
yeah, you can go.
Tell me which problem.
Question number 8.
8.
Yeah, 8 or 9. Yeah,
This one.
not this one, ma'am. I think.
This one.
No. The question is about the drugs.
This one. 5. Is it the question?
Yes, ma'am. Yeah, question number 5. Uh, how can we find beta? I mean, here is how can we decide the alternative hypothesis? Because yeah,
How did you decide your null hypothesis?
here it is given, na ma'am. The null hypothesis is probability is equal to 1 by 4. But for the alternative, it is probability is
So,
not
okay.
equal to 1 by 4.
So
Is it?
null, okay, here it is null is given, right? We
Yeah.
reject the null that p equals 1 by 2 and the new drug will be considered superior to the one presently in use.
Mm-hmm.
See, uh, read the first statement. It says a commonly prescribed drug for relieving nervous tension is believed to be only 25% effective.
Mm-hmm.
Now, to determine if a new drug is superior,
Mm-hmm.
okay? So if I want to say like something is superior, it means I want the probability to be more than 25%.
Right.
What I believe is right now that it is
Mm-hmm.
just 25% effective. It means P is 25 by 100, that is 1 upon 4.
4.
But
Yeah.
I have manufactured a new drug has been prescribed, and now I want to check whether if this drug helps in relieving the nervous tension or like it is whether it is better than the previous one or not. So it means
Okay.
I want to check whether the P that was initially 25%
Mm-hmm.
for this new drug, whether this P becomes greater than 25%. Okay. So
Okay.
this is what we want to check. We want to check whether P is greater than 1 by 4 or not. So I will take my null to be 25%, that is 0.4.
Mm-hmm.
Sorry, 1 by 4, and the alternative to be P equals greater than 1 by 4. So a null hypothesis that we generally believe to be true. So it is given to us that it is 25% effective, that I am taking as null hypothesis. Now, if I want to check something is greater, that we will take
Mm-hmm.
as alternative hypothesis. That's it.
Okay. Okay. And in the question, it is given superior. That's why we are taking that alternative hypothesis should be greater than 1 by 4, right?
Yes.
Okay. If it is not mentioned, some like it is a superior, I mean,
Something
it is greater than
something
25.
something will be mentioned in the question. Like, let's see here. Okay, let's see this. It says
Mm-hmm.
a manufacturer supplies fuses, approximately 90% of which function properly. All
Mm-hmm.
right. This statement has been given. This statement has been made that 90% of whatever fuses the manufacturer supplies, it
Mm-hmm.
function properly. Now he has initiated a new process whose purpose is to increase the proportion of properly functioning fuses. right? So initially, if it was 90%, there has been some process that has been done to increase the functioning capacity. Like if it is just 90%, now it should be more than 90%. All right.
Okay.
So I want to check whether it is the new method that has been introduced, whether it is helping in initiating this 90% or not, whether it is going to be greater than 90% or not. So if so, in this case, I will take my null to be p equals 0.9 that is given to us, and the alternative to be p greater than 90%, right?
Okay.
Because this is what I want to check, whether it is helping in increasing the proportion or not. So you look at any problem, it is always being mentioned what is what is it that you will have to take the null hypothesis to be and alternative to be. Look over here that it says the average marks scored by students is reported to be 400. Okay, so this is what the statement that has been made, that the average is 400. But what you suspect is the average may be lower. So you want to check whether the average that is given to be 400, whether it is actually lower or not. Right. So you will take your null to be 400, and since you want to check that the average is lower, you will take your alternative to be mu less than 400.
Ma'am, can you hear me now?
Yeah, I can hear you.
Can I speak?
Yeah, sure.
Yeah, ma'am. So I'm asking for activity 11.7.
Yeah, I have
Yeah,
asked you what is a null and alternative there. You
yeah,
didn't
yeah.
reply.
Can you open that slide, ma'am? I will explain.
Okay.
Yeah, so in this one, the standard deviation is given for the first one is 9 and the second one is 12. So if we divide 9 by 12, so it is less than 1. So we can say Sx square upon Sy square is less than 1 minus Cl. So we have to reject on that one. So that's
First you tell me what is the null hypothesis and what is alternative hypothesis.
Ma'am, null hypothesis we have to reject when we have 1 minus Cl, like Sx.
No. I mean, what is null hypothesis? Like before starting any problem, you define what is a null hypothesis, what is an alternative hypothesis, and then you define the test. So I am asking is like, what is a null hypothesis?
So in that case, when we have to reject on the condition like Sx square upon Sy square,
No.
but
Like
is less than 1.
what is the that you want to check? Like any
So,
problem I take, we
yeah.
say this is my null hypothesis, this is my alternative hypothesis.
If the standard deviation of average marks is the same, both the classes like standard deviation and this one, with the significance level, this are the same on.
So what is H naught?
H naught is Sx square upon Sy square.
No, H naught is like sigma 1 equals to sigma 2. Right.
Then here is sigma is given.
It is not given, but this is what you have to check. What is you have to check? You have to check that this whether the standard deviation of average marks of both the classes are same. So what I am like whether it is equal to or not equal to, right? I mean whether they are same or different. So what is the null hypothesis I will take is let's say like the standard deviation is same for both the classes.
Okay, got it.
Sigma 1 is equal to sigma 2, right?
Yeah, got it.
Yeah.
Now got it. So the second one is alternative is sigma is not sigma 1 is not equal to sigma 2, and then after that we have to accept and reject according to that. Am I right?
Yes.
Okay, got
So
it.
unless you define what is your null hypothesis, what is your
So,
how can you describe the test?
Okay, got it. Thank you, ma'am.
Okay. It's already been 8, so most of the part has been covered. Like again, you just go back and try to just solve few problems. So there's one more session on Monday with Professor Andrew, and then there will be 1 or 2 more sessions. So one is scheduled on Friday, that is for sure, and there will be one more that will be informed to you. So till then, you like practice the problems from estimation and hypothesis testing.
Ma'am, mock is compulsory or we can skip that?
You can skip the mock, but if you want to time yourself and check whether you are able to solve it.
So basically, ma'am, from we can say from 8 to 11, I have prepared, and the remaining are just left. So that's the thing. I'm confused.
Yeah, it is fine. Like you can still score well if you have done those two topics properly.
Ma'am, stats,
How much?
we can't say that I prepared everything. So that's the thing.
Yeah, how many questions can we expect in the final quiz?
So tomorrow mock you will get to know, like almost everything is similar.
Ma'am, like
Okay.
15 to 20 question, I think the same one we have done.
So there won't be any word cloud kind of question this time, but yeah, there has been a specific pattern. So
I'm like NAT is more or like it's a equal
so
MCQ and
mock and the quiz paper is almost same, like similar pattern. So I will suggest please like even if you don't do the time mock, can't do it tomorrow, just time it yourself sometime again later and just try to solve it. You will get an
Okay.
idea for like how many questions and all are going to come.
Okay. Okay. Thank you. Thank you.
Yeah, thank you. So we can close the session for today.
Yes, ma'am.
Yeah. Thank you for joining. Yeah.
Yeah.
Karthik, can you close the session?